everyone, welcome back to another video of LeetCode Daily Challenge Streak series, and in today's video we have a new question that says longest common subsequence. Now let's understand what this question says. Now you will be given two strings, consider it to be S and T. Now given these two strings, you are supposed to return the longest common subsequence among the given two texts. Now let's consider this example A, B, C, D, E, and this to be S, and A, C, E to be T. Now what are some subsequences that we can write out of it? Subsequence is something that is framed out of this particular word, but it need not be continuous. Like it is not mandatory for all the elements to be consecutive. You can pick the elements in non-consecutive order also, but they should be in the same direction. Okay. Now, what could be some subsequences that we can generate from this? It is A, AB, ABC, ABCD, ABCDE. Now since I told you that it can be non-consecutive elements as well, so we can add stuff like AC, ACD, ACE. Okay, and then again ADE, AE, or AD as well. Now something like that. And then for B also, again you'll have BCDE, BC, BCD, and BDE. See, the order is picked from this, but they are not consecutive elements. Okay, or BE, they are not consecutive elements. So given this word, you are supposed to generate. Now if you take this example, it would be A, then AC, then ACE, then CE, or AE, and next you'll have C, and then you'll have E, and then CE, and okay. Now if you look at this carefully, this ACE and ACE is common here. So what is the length of these subsequences? It is 3. So this is the longest sequence that you can find, the longest subsequence that you can find between these two elements. So you will return 3. Okay. Now what is the brute force approach that we can follow to return this? It is just that we will generate, okay, we can generate all subsequences. We can generate all the subsequences out of these two elements, then compare each word to each word, and then compare each word and then check their lengths and store the maximum value. Whichever strings are same, we will return them. So we will check for the same subsequences. Whichever subsequences match, their length will be updated, and out of the lengths updated, the maximum one will be returned. But the time complexity for generating all subsequences and then comparing each one of the subsequence with the other word subsequence would take a lot of time complexity. Okay, would take a lot of time complexity. Now, can we think of another way to solve this problem? Now, if you consider the example ACE and CED. Now if you carefully, or ACD and CD, consider this example ACD and CD. If you carefully look at this example, you can see that the longest common subsequence is CD and CD. Okay, it is CD here and CD here, and the length of this is 2, so you will return 2. Now how do we solve this problem? Let me write it again, CED. Now what we can do is, we can start comparing. For you to compare the elements, you need to have 2 indices, correct? 2 indices. Now usually when you are solving problems where you are supposed to explore all the possibilities, you write it in the form of an index. You write the function. Okay, you write the function in the form of an index. But since you need 2 different elements, because once you might be comparing this element with this element, or you might be here and you might be comparing with the first element. So you're not constantly using the same index. Like if you are at 2, you're not comparing 2 here also. Sometimes when you're at 2, you're comparing it with the first index, as in the 0th index as well. So you will need 2 different indices to compare the values. So index 1 and index 2. Now what is f of index 1 and index 2 here? This function represents the common subsequence till index from 0 to index 1 and 0 to index 2 in this particular string. In in the first word it is 0 to index 1, in the second word it is 0 to index 2. So we are returning. So if you are at f of 1 comma 1, it is that we are trying to return the length of the common subsequence from 0 to index 1, as in from 0 to this index as well as 0 to this index. If it is f of 1 comma 2, then in first word we are trying to return the common subsequence from 0 to 1, and in second word we are checking it till 0 to 2. So we are comparing among these elements. Okay, this is what it means. Now let's start from index 2 as in the last index, and then we'll be moving backward. You can start from the forward and go this way as well, but I'd prefer starting from backward and going in this direction. Now you're currently at D. Okay, you're currently at D and your element has matched. Okay, your element has matched. So let me write down this function back again. It is index 1 and index 2. Now whenever this is index 1 and this is index 2. So whenever the index 1 and index 2 matches, what are you doing? It means that you got length of one common subsequence. Okay, this is one letter and this is common. So one letter out of these whole words are common for now, correct? So it means that for the common subsequence, for the length of common subsequence, 1 can be added since one letter is common. So 1 plus. Now what will you do when same indices are there? You don't have to compare it with anything. When this index and this index is same, would you go back and then still compare it with this? No, you found a common element. Now you would go back and compare the previous elements. Okay, you will compare the previous elements. Now when you are going back, what happens to your index? Your index gets decremented by 1, correct? So when the elements, if S of index 1, okay, since this is S and this is T, is equals to T of index 2, since this is T of index 2, okay, then what are we doing? We are adding 1, as in we found one common letter, and then we are decrementing these indices and calling the function. So f of index 1 minus 1 comma index 2 minus 1. Next, what is the otherwise case? What is it means that there were different letters here. For example, CE and EC. Now you are at index 1 and you are at index 2 here. Okay, now you are here. Now what if these letters mismatch? Now you might be thinking, these letters mismatched, so I will go forward and check. Now if you do something like that, you have C here. If you had stayed here, okay, let me pick a different color. If you had stayed at C here and then moved this forward, then the C and C would have been a match, correct? You would have found C and C as a match. But if you move both the indices at the same time, you won't be able to find the match, correct? Because you are missing out on C and C because you are moving both the indices, correct? Which is why. And likewise, if you have E and E here, and if you moved this one and you stayed, and if you moved both the places, you are missing out on E and D, correct? Otherwise, if you moved one index and if you stayed right here, then you would have been getting E and D match as well, correct? And out of both the things, whichever one would be maximum, that thing would be added, correct? If you move both those at the same time, you will be missing a match. But in either of the cases, if you move only one index and stay there, you might get a match, correct? So in otherwise case, what it is, you will just return 0 because you didn't find a match. But what function are you calling? You are calling, it's either f of index minus 1. You either move this index 1 minus 1 comma index 2, or you are moving the second index as in index 1 comma index 2 minus 1. Okay, you are either moving this index or this index. Now what are you checking in the end? You are checking the max of these elements. Okay, you're checking if this element is giving you max or this element is giving you max. Okay, now what is our base condition? Now that we have written match or no match as condition, what is the base condition? It means that we have reached our destination. So for example, you are at A, C, D and C, E, D. Now you have reached here and you didn't find a match. Now you want to go to the previous index, but there's no previous index, correct? So from 1, 0 minus 1 becomes minus 1. Now, if there is negative element and if there is nothing here, you're not comparing this with any element, correct? When there is no match, you can't compare nothing with some element. So, in that case, what happens? There is no maximum length, correct? There is no maximum length. So, if index 1 is less than 0, or even this could go, correct? You are here and index 2 minus 1 happens. So 0 minus 1 is minus 1. In this case also you don't have anything. So if index minus 1 or index 2 is less than 0, if either of them are done with the words and then they are falling out of the word, then what happens? We will simply return 0 because there is no maximum value to be compared, correct? There is no maximum value to be compared here. The length is 0. You can't compare an empty element with the element here. So the length of the common subsequence in this case, in the base condition, will return 0. Okay, just this is the matching condition where the letters match. You will just move both the indices. If it's not a match, then you will move one index and check it, or you will move the other index and remain and let the second index be as it is. Now, what will be the time complexity of this approach? Since this is recursion, for two words, you're traversing through all and you're checking through every element, correct? For both the words. So for both the words, you're checking for m times. You're comparing it with m times. So 2 power m into, and also since assuming that the length of the t word is n, it will be 2 power m into 2 power n, which is exponential, which will give us a time complexity problem. Now, how can we optimize this thing? How can we optimize the recursion? By using the DP array, correct? By using the DP array. Now, since we have two indices, what do? We initialize a DP array of size m by n, okay, of size n by n. To what do we initialize it to? We initialize it to minus 1, okay? We initialize it to minus 1. So, what do we do? Simple, very simple. What are we doing here? First we check, like I explained in the previous videos, if dp of ij is not equal to minus 1, we return dp of ij. Okay? Otherwise, okay, it means that we already came across that value previously and we updated it. So the value has been changed and we return it. Now, what if the dp of ij value is still minus 1? So what will we do? Instead of returning this value here, you will just store dp of ij here. And likewise in the otherwise case also, instead of returning this directly, you will store in dp of ij and then return dp of ij. Okay? Instead of returning those values directly, since dp of ij value is here, it will be stored and you are passing dp array in this function. So in the main function, how will you call? Since if it's A, C, D and C, E, D, and assume this to be of length m and this to be of length n, you're starting from this last index, which is m minus 1, and this index n minus 1. So how will you call your function? You will call your function in the main function to be m minus 1 comma n minus 1. You will start your function, you will start solving it from m minus 1, n minus 1 and gradually keep going backwards until you reach 0 or beyond that. Okay, so the time complexity for this one would be O of n cross m, because we are traversing through all the elements, n cross m elements, to update the DP array. And the space complexity would be O of n into m plus O of n into m. Why? Because we are using a DP array of size n into m or m into n, and O of n into m as the auxiliary stack space. Okay, so let's quickly code this up. We have a function longest common subsequence given, in which we have two inputs, text1 and text2 given. So instead of text1, let me use the letter S for convenience and easy writing of code. And instead of text2, I will use the letter T. Now, what are we doing first? We want the length of the string S and length of the string T. So let it be m and n. Next, what are we doing? We are writing another helper function. Okay, and helper function where we'll be sending two indices, I and j. We'll be sending two indices and also our strings. Okay, because we'll be needing s of I and s of j. So for that, we'll be sending our strings. Now, what are we doing? What is our first condition? If s of I, as in if they have a match, if s of I is equals to t of j, then what is happening? Our count will be increased by 1. So our count will be increased by 1 and our indices will reduce by 1, as in they'll be going backwards. So helper of I minus 1 comma j minus 1 comma s comma t. Now, what if they don't match? What is the otherwise case? We will return, we are supposed to return this, okay? Return this. Now, what is the otherwise case? We will be returning the max of either the one index to be reduced or the other index to be moved backwards. So, max of helper of I minus 1 comma j comma s comma t, or you move the second index, which is helper of I comma j minus 1 comma s comma t. Okay, now what is our base condition? Base condition is that if I is less than 0, or the first index moves outside, or j moves outside, as in the second index moves outside, it means that we can't compare it with any element. So we will directly return 0. Okay, we will directly return 0. Now in the end, what are we doing? We are just returning this helper function. Where are we starting? Since we are starting from the last indices, so what will be the indices be, since it is m and n here? So m minus 1 comma its last index, n minus 1 comma, and we are sending strings s and t. Okay, now this is the recursion. Though the code will run, see, the code runs, but if we try to submit it, I will show you how it will throw a time complexity error. See, it's taking so much time to, even run and compile the code. So it means that there's time complexity and it's unable to compute. See, I set them. So the time limit has been exceeded. Now, how do we solve this problem? We take a DP array. So we initialize a DP array. Okay, we initialize a DP array. Okay, into m for I in range n. Okay, now what are we doing? We are sending our DP array in all these functions. Okay, we are going to send the DP array in all these functions here. DP and DP. Okay, next, what are we doing? We are just checking here before we get into the details of this. If in case we have, if dp of ij is not equal to minus 1, as in the value has already been computed, so we will return dp of ij. Let me just copy paste this thing. Now, otherwise, instead of returning this thing directly, we will store it here. Okay, we will store it here, and then we are going to return dp of ij. Likewise, instead of directly returning this here, we are going to store it in dp of ij and then return dp of ij. So let's quickly run the code. It's accepted, and let's submit it now. So this is accepted now. Thank you guys.